Alright, so yeah, if we start with this, we've got a mole, and the easiest way we're describing it now is it stands for an amount of a substance. So the mole is a name for a specific number, and we're going to talk about that number next. The mole is the SI unit for a quantity of substance. Okay, 1 mole is the amount of a substance having the same number of particles as there are atoms in 12 grams of carbon-12. Now I know that makes absolutely no sense. I'm going to describe it because it's a concept that you have to get used to. So let's just open up another page and let's talk about what that means. So if you have your periodic table in front of you, if you don't, please try to get it out because we're going to refer to it now. Right, so I'm just going to open up a page so we can write some notes here. Right, so we're saying we've got this concept of a mole, and we're saying it's a unit of measuring something. So a unit of measurement, basically. Now, if you have your periodic table in front of you, I want you to go to carbon. Carbon, and you'll notice, let me just open it up here in case you don't have it. Okay, here's our periodic table. So if we zoom into carbon, we can see here. Firstly, we notice that carbon has 6 atoms in it, and then we notice that the relative atomic mass, don't forget that, is at the bottom here, the bottom number. The relative atomic mass for carbon is 12. Okay, so that's important to take note of. So we see that carbon has a relative atomic mass, I'm just writing it in short form, of 12. Now what scientists have done in order to get this unit of measurement to be a mole is they've taken this carbon atom and they've said, let's take this atom and let's use it as our unit of measurement. Okay, so everything about the mole is based on carbon. So that's just, we first have to understand it. Because if we look at our definition, we describe it, if we were to talk about 1 mole, we're saying 1 mole is the amount of a substance having the same number of particles as their atoms in 12 grams of carbon-12. Okay, so it's a bit of a weird definition we have to get used to, but again, what this basically means, this last part of the definition, as there are atoms in 12 grams of carbon-12, all you need to understand about that is they used carbon-12 as the unit of measurement. So it's almost like they were starting a new counting system, and in order to start the number line, they started looking at carbon-12 first. So that's all it means. So let's understand what a mole means a bit further. So I do have an example that can help us understand it a little bit better. And it's kind of talking about, let's imagine that we've got a big bag of candy, sweets inside here. Okay, so you've got this bag and you've got a whole lot of sweets in here. And you basically want to know how many sweets are in the bag. But you don't want to count them one by one because there's so many sweets in here. We don't know how many, right? There's just so many that we don't want to go and individually count each one. So what the scientists did is they came up with a special way to measure the number of sweets or any other tiny particles. So let's pretend like the sweets is what we want to measure, right? But because there's so many sweets in here, we don't want to measure it one by one. So we need to come up with a new counting system. Right? So this is exactly what scientists have done for atoms. If you think about this big bag of sweets, that's a similar thing to an atom. If this is an atom, we know that atoms are very small. If you think about a glass of water, right, we know that there's H2O molecules in here. But think about how many small atoms there is in that glass of water. There's so many that you can't even see it with your naked eye, right? And the reason now is that if we wanted to say how many atoms there are in this glass, we can't even put a number to it because it's so large. So what the scientists have done is they've come up with a new way of counting the number of atoms, and they use that unit of measurement to be called a mole. That is the best way to understand what it is. All right, and as I said, how they developed this whole system is they looked at carbon-12 and they based everything off that atom. All right, so that's a very basic introduction to what a mole is. Now, a mole, interestingly, it can refer to any sort of particle. It doesn't have to be only atoms. You can use a mole to describe how many atoms you have, but you can also use it to say how many particles you have or how many molecules you have. All right, and we'll talk about this more when we get into an example, but it's not restricted to just being atoms. Okay. So the next thing we're going to talk about is something called molar mass, right? You may have come across this again in grade 10. And molar mass, let's just open up a new page so you can write notes as well. Alright, so if we want to talk about what molar mass is, your guideline definition defines molar mass as the mass of one mole of a substance measured in grams per mole. Okay, so it's a very short definition. The easiest way to understand what this is in your head is like someone took the substance, they put it on a scale, and they measured the molar mass. Okay, so grams per mole. The amount in kilograms per mole, right? And we're going to see how we get this number. We have to use an equation to get to it. So molar mass is basically calculated by adding up the atomic masses of all your atoms in a molecule. To calculate the molar mass of a compound, you need the chemical formula. All right, so I'm going to show you the easiest way of how we calculate it first, and then we'll do some examples to practice it. And again, I need the periodic table, so I'm just going to copy and paste it. Okay, let's go through an example. Let's say, number one, I wanted to know what is the molar mass of, let's start with just one atom, of carbon, right? The way I calculate this is by going firstly and finding the chemical symbol, right? So we locate carbon. Carbon is here. The molar mass of carbon is indicated by the number at the bottom. So technically our molar mass of carbon should just be 12, right? But what happens now if I want to know the molar mass of, let's say, H2? Okay, H2, if we think about the structure of this molecule, there's two hydrogen atoms, right? So the first thing I need to do is I need to find my symbol. We know it's the first element. We know that the relative atomic mass is 1. But in order to calculate the molar mass, I need to have 2 hydrogen molecules. So simply what we just need to do is we need to add both molecules together, and then we get an answer of 2. Alright, so this is how molar mass works. Same thing, and now we're going to start practicing a few more examples. Let's say we have carbon dioxide. How do we calculate the molar mass? So let's just do this one as an example, and then I'll give you a few to do on your own, and we'll do some practice. So if we're looking at CO2, and this is why I said the first thing when you start calculating molar mass, let's just write some notes here. Whenever you need to calculate molar mass, you can think of it as the first step you always need is your chemical formula. Because this is going to tell you what substance you have, right? What individual atoms you need to go look up. So you always start with the formula. So let's look at CO2. CO2, we know the formula. We know we've got a carbon. So let's actually go find carbon with a 12 relative atomic mass. And we also have oxygen with a 16 relative atomic mass. Now, in order to find the molar mass, we basically just need to add up each of the individual atoms in this substance. So let's just draw a picture for ourselves. We know we've got one carbon atom, and we know we've got one oxygen and another, right? O2, two oxygen. So we first have to find, let's just write it as the molar mass of carbon plus the molar mass of oxygen plus the molar mass of another oxygen, right? We looked that up. We found that the molar mass of carbon for one carbon is just 12. The molar mass for one oxygen is 16, and another one would be 16. Then you add up all these numbers, and then you find the molar mass for CO2. So it's pretty simple enough. All you're doing is you're just looking at the chemical formula, you're going to your periodic table, you're finding your relative atomic mass, and you're adding that in your formula. Okay, so now we're going to try a few examples where I give you and then we'll mark it once you're done, just so we get the hang of how to do this. So I'm going to write them down here. So the first one we want to look at is H2O. Then we want to look at CO2. Okay, we've done CO2, so let's leave that out. So if you don't have a periodic table in front of you, I suggest getting one, but I will open up the one on my screen as well. Okay, I think 4 examples should be enough for us. Okay, so you guys are going to work on these 4 examples, and then when we're all done, we're going to mark them. I'm going to try and keep this open so you can use it if you need to. No, I'm having a lesson in the middle of everything, so I'll speak to you once that's done at 2:30. Okay, so I think we're ready to mark the work. Okay, so as we're doing this, I'm also going to show you the structure of how we write down the equation, just so it makes sense in your head of what you are calculating. So I'm going to do it at the bottom here. Let's start with H2O. And I should tell you that the symbol for molar mass is a capital M. So whenever you refer to molar mass, we use a capital M. And also don't forget that the unit of measurement is in grams per mole. Okay, remember in physics, when you're writing grams per mole using the dot doesn't go at the bottom, doesn't go at the top, it goes directly in the middle, and you've got your mole, and don't forget to show the inverse, right? So if we are calculating the molar mass of H2O, so take note of the notation. This means I want to calculate molar mass of the substance in the brackets. This is going to be equal to, what do? We know we've got 2 hydrogen molecules and we've got 1 oxygen. So we first need to go and find the relative atomic mass of hydrogen. If we go to our periodic table, that is 1. Okay, so there's 2 ways you can write this out. I prefer using the bracket method. So because we know that there's 2 hydrogen molecules, we can put the 2 on the outside and multiply it by 1, right? All that means is, because I have 2 of the same substance, here's the 2 on the outside and here's the relative atomic mass. If you say 1 plus 1, that's also fine. Okay, and then we're adding that to the oxygen. So if we go to our periodic table of oxygen, it has a relative atomic mass of 16. So we're adding this to 16. Okay, and we get 18 grams per mole. Alright, let's do the next one. We've got NaCl. So again, I want to find the molar mass of NaCl. Okay, so first you can go and look up your relative atomic mass of sodium. If we do that, we find that sodium has a relative atomic mass of 23 plus chlorine. If we look up chlorine, we've got 35.5. Okay, NaCl, and we should get an answer of about 58.4 grams per mole. Okay, remember that if you leave out your unit, that is not good. You always want to include that unit there. So it should actually be 0.5. And then the next one we have is CH4. So we want to find the molar mass of CH4. So first we're going to look up the molar mass of carbon. And we know that it is 12. Plus, now we have hydrogen. How many hydrogen atoms do we have? 4. Okay, so we put a bracket there to say we've got 4 of that one molecule. And if we look up hydrogen, we've got a relative atomic mass of 1. So we've got that. Okay. And then lastly, we've got a bit of a longer one. So also take note that whenever you have chemical symbols, you're not restricted to just having 2 different atoms. You can have more than 3 even. So this is an example of a more longer one. So we want the molar mass of C6H12O6. Alright? So here I think it's important to look at the brackets, right? It'll make more sense using this example. We've got 6 carbon atoms, so we'll put the 6 on the outside and we'll leave space here for whatever the relative atomic mass is. We're adding that to 12 hydrogen atoms, and we're adding that to 6 oxygen atoms. So take note of that. Okay, so we can clearly see how the bracket makes sense now. So let's go and look up carbon. Carbon we know is 12, right? And then we have hydrogen, which is just 1. And then we have oxygen, which is 16. So there's no need to show simplification. You can go straight to your answer here, and that should be 180 grams per mole. All right. So now we should be very comfortable with calculating molar mass. As I said, it's not too complicated. The only thing you need to make sure you have is your chemical formula, because that's going to tell you what substance to go and look up. I have a table where we can actually practice a bit more, but I think I'll give you guys that to do on your own. But again, this is a very important basic step that we need, especially moving forward. So now that we understand what molar mass is, we need to understand how it actually is used in chemistry, why we're even doing this in the first place. So we've been talking about a mole, we've been talking about a molar mass. And this is all important because when chemists and scientists come together, they want to be able to always measure the mass of whatever substance they have. We just spoke about going from reactants to products. And so when they do these calculations in the lab, they want to measure these substances. They want to check if there's a conservation of mass. So we start with an important formula now that helps us to do these calculations. And we're going to explain it. Okay, so we have this formula here. The N in the formula stands for the number of moles that we have. Okay, the number of moles that we have. And the unit of measurement for the number of moles, I'm just going to write it on the side here. So what this means is if you have, for instance, if I was talking about mass, well, let's choose the easier one, distance. If I was talking about distance, the unit of measurement we know is meters. If I'm talking about the number of moles, the unit of measurement is the mole. But it's spelled M-O-L, not M-O-L-E. Okay, so take note of that. So whenever a calculation asks you to calculate the number of moles, your unit is always written like that. The M we've just done, the capital M rather, so let's start with that. That refers to our molar mass. Okay, and we know how to calculate that using our periodic table. The unit of measurement for molar mass is grams per mole. Alright, and we've got our small m, and the small m is just a measurement of the mass of the sample. Alright, this is the same thing as taking that substance and putting it on a scale, and your scale telling you so many grams. Okay, so that unit is just grams. Alright, so this is the basic formula we have, and as you can see now, why we need to study it. If you have your molar mass and you have your mass of your sample, you can go ahead and calculate the number of moles. So as long as you have at least two of these quantities, you can always calculate the third, right? So I'm going to give you a minute to just take down what I've written down, and then we'll go through a few examples, understanding what this all means. Alright, so let's actually start doing a few examples with this. And remember, as with all these equations in physics, I always tell you guys, make sure you know how to change your subject of your formula. In this case, you can see you've got N, right? You've got your number of moles as what you are calculating. But you must always make sure you know how to change it. If you wanted to calculate molar mass, right, we need to understand how to write the formula using molar mass. Okay, and all that means is we are cross multiplying here, so M is equal to, okay, so this is the formula for molar mass as your subject. And then if you also wanted to calculate the mass of your sample, then you are just also multiplying so that M is equal to, so just make sure you understand these three equations. So we've got number of moles, we've got the mass in grams, and we've got molar mass. So it makes sense why this is called molar mass now. I hope you figured out that. It's called molar mass because you're dealing with moles, firstly, and then you're dealing with your normal mass. Alright, so let's practice an example of how we use this equation. So let's say we wanted to calculate Alright, so this is the question. We want to calculate the number of moles of water in 100 grams of water. So everything you need is in the question. The equation is also here. I'm going to give you guys a minute to try this and then we'll do the answer. Alright, let's have a look at how do we do this. So firstly they want the number of moles. The number of moles is N. Right, in water. So take note that they didn't give you your chemical formula here. But we all know what water is, right? It's H2O. They gave you your mass of your water. They told you that it's 100 grams, so let's just highlight that. So this is your M, right? So if we write this down, we don't know what N is, we want to find it. We are given small m, the mass of the sample, to be 100 grams. Can we find the capital M? What do we need? We need the formula, the chemical formula, which we should know by now, right? It's water. So we need to actually first calculate what is the molar mass of water. Right, so if we do this from our periodic table, we've got 2 hydrogen atoms, which is 1, plus oxygen, which is 16. The molar mass of H2O is going to therefore be 18 grams per mole. Right, so now we actually have M, small m, and we've got capital M. Can we calculate the small n? Can we calculate number of moles? It's going to be simply just plugging into the equation. What is our equation? N is equal to, and I think they do give you this equation in your paper. So small n is equal to small m over big M, and we've got 100 grams all over 18 grams per mole. Okay. And if we do this calculation, we should get 5,56. Remember your unit of measurement. We've got N. N stands for number of moles. We write it as that. Okay, so we see how we calculate number of moles now. It's a weird concept to get used to, but when you're using this equation, it makes sense because all you need is your molar mass, which you get from your periodic table, and you need your mass in grams. So I'm going to write down the second example, which you're going to try all on your own, and then as usual, we'll mark when you're done. So example 2, we want to calculate Okay, so just work on example 2, and then when we're done, we will mark that. Okay, so let's read the question. We've got, what is the molar mass? So we want to know molar mass, which is capital M, of a substance. If you've got 5 moles, so they're telling you your small n is equal to 5 moles of the substance, and it has a mass, which they're also giving you. So your small m is equal to 295.5 grams. Alright, so we go to our equation, which is n, n is equal to small m over capital M. As I told you, we need to be able to always change, right? Because now we're solving for big M. So if we rearrange, we get n times capital M equals to small m, and then we need to divide by n on both sides. So we get big M is equal to this. Alright, and now it's just a case of substitution. So we have 295.5 grams all over the number of moles, which is 5. And if you calculate this, you should get an answer of 58.5 grams per mole. Alright, so not too difficult, this question. Okay, so we're just going to practice a few more of these just to get the hang of it, because they do sometimes ask this in a way where you have to kind of think out of the box. So let's just do a few more of these and get comfortable with that. Okay, so example 3 is telling me they want you to calculate Okay, let's do the first one, and then when we're done with that, we'll do 3.2. So they want the number of moles in 2.5 grams of NH3. Just going to write the formula out here again. Okay, and if you need the periodic table, just let me know in the chat, because I can't really see the question if I move the screen. Okay, so 3.1, we want to calculate the number of moles. So writing down our little equation here, n is what we do not know. They're telling us that small m is 2,5 grams. So therefore we obviously need to go and calculate capital M of NH3. Right, so we need to go to our periodic table. We need to find out what is the relative atomic mass of nitrogen, and then 3 hydrogen atoms. So nitrogen and hydrogen. Nitrogen has a relative atomic mass of 14, and hydrogen has a relative atomic mass of 1. So we have 14 and 1. Okay, and if we calculate that, that is simply 17 grams per mole. Okay, and then we have our formula. And now, since we know what small m and big M is, we're simply going to substitute. So we have 2,5 grams all over 17 grams per mole. And if we calculate that, we should get an answer of 0,15. And don't forget your unit as that. Okay, so again, not too bad this question. Let's try 3.2. So in 3.2, they still want you to calculate the number of moles, but now they want you to calculate the number of moles in 213 grams of chlorine, right? Chlorine 2. Okay, so we seem to have gotten used to this now, I hope, and it's becoming clear now what we need to do. In this case, we still want to calculate number of moles. We have small m to be 213 grams, and obviously now again we need to calculate molar mass of Cl2. Now again, this is dichlorine, right? So you have to put your 2 in here, and then you're going to go look up your relative atomic mass for chlorine. If we do that, chlorine gas, we have 35.5. Right? So if we calculate that, that should be 71 grams per mole. And again, a simple case of substitution into the equation. So your answer should be 3 mole. Right, so hopefully we all got the hang of this now. If we don't, I think I'll make a few practice questions with answers so you can actually practice this, because it's an important skill for the rest of the term's work to follow. But I hope you notice, especially when we get answers in mole, if you look clearly, you'll see that those are very small numbers, and that's proving why we need to use it as a new measurement system. Because as we said, if you've got a glass and we've got all these atoms inside here, it becomes very difficult to write down huge numbers, right, like this. So we're using the mole, which becomes an easier method of measurement. So for today, that's going to be all the practice questions we do. So mastering how to calculate molar mass and also using this equation. But I'm quickly going to talk about an introduction to the next week's work, because that is going to be proper questions in your exam that they like to test on. So let's just quickly have a look at that. Alright, so if you notice on the guideline, this is always our checklist to make sure we've covered everything. So we started last week where we just briefly touched on chemical equations. We still need to have a lesson, which I'll do next week, on how to balance chemical equations. It's an important skill, so I want to take some time to actually show you the tricks of how you can do it, right? And then, so we actually did cover most of this, so Today we've covered the mole concept, right? We described the mole as a unit of measurement. 1 mole, we said, is the amount of a substance having the same number of particles as there are atoms in carbon-12. Next week, we'll start talking about something called Avogadro's number, right? It was basically a person who actually studied this, so they actually named the number after him. And Avogadro's number is going to tell us the number of particles, whether that is atoms, molecules, or formula units that is present in 1 mole. And your hint is, here's the number, it's actually 6.02 times 10 to the 23. That's going to be an important number that we start using in our calculations. So I don't want to rush it. I want to explain it properly to you when we're doing calculations. We also today touched on the definition of molar mass, right? It's the mass of 1 mole of a substance measured in grams per mole. And we need to be able to calculate the mass using, well, given its formula. So today that is what we covered, but next week we're going to start talking about the gases. We're going to start talking about Avogadro's law. And in order for us to cover Avogadro's law, we have to do a little bit of a recap of volume and gases. So I'm going to quickly just touch on that now. We will go into it more next week, but we're going to talk about the ideal gas law. Right, so if you do want to study further ahead, you want to look at videos, then it'll be a good place to actually start with. Just understanding what the ideal gas law is. We're going to talk a lot about Boyle's law. Boyle's law is the most popular law that's going to come out in your exam. You'll have a whole question on Boyle's law, so making sure we can do calculations with volumes and gases. Alright, and then the main things to understand about Boyle's law is we're going to deal with 3 different characteristics about gases. We're going to be dealing with temperature, pressure, and volume. Right? These 3 things must exist together. So we're going to actually do a whole lesson where we look at if I've got a cylinder, what is going on if I change the volume, so pressure and temperature, and so forth. So if you want to do some reading on this part in preparation for next week's lesson, we're going to be doing a lot of calculations and I'm going to be moving a little bit faster so we can practice more exam questions. Then this is the place you can start with. Right, but other than that, also I just want to show you that I actually just start making a study checklist first, which is as we start moving ahead with the work, I'm going to be putting on points here. So even when you're studying and when you're coming to lessons, making sure you go through these points and understand each of these points. If there's ever a point in time where you feel like you don't understand something, then stay back and ask me and we can go through it. And also a definition page. You should be doing this for yourself as well. But at the end of the term, when we're done with the section, I'll send this on the group. You can print this out, and it's basically each definition we have from the guideline, so that you can learn it as we go with the section. So you're not stuck with learning 12 definitions before your exam. Alright, so with that said, I think that is it for today. As I mentioned as well in the group and last week, we will not be having our lesson on Thursday. We're only having 1 lesson this week, but lessons will resume the following week. So I think that's the week you go back to school. Lessons will resume on that week, Wednesday. Okay, if you don't have any questions or anything else, the lesson is done for today. Take care, guys.